Good morning, students. Today we will discuss problems related to the topic laws of motion. So starts with the first question, right? So in the question, a constant retarding force of 15 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meter per second. How long does the body take to stop? Right? So here they mention force, so that is the retarding force, so that is 50 Newton. That means the force is negative. Next, they mention the mass of the object, that is 20 kg, and initially the object is moving with a speed of 15 meter per second. That means the object is moving with some initial velocity. How long does the body take to stop? Means we need to find the time after applying the retarding force. So retarding force apply ಮಾಡಿದ್ರೆ object ಏನಾಗುತ್ತೆ, it comes to stop. So how much time it will take to stop, right? So consider one object. So this object is applying the force, sorry. So this object is moving with some velocity, that is u is equals to 15 meter per second. So ನೀವು ಯಾವ direction ಬೇಕಾದರೂ consider ಮಾಡಿ, right? Initially it is moving with 15 meters per second, and that object having the mass, that is m is equals to some 20 kg, right? A constant retarding force of 50 Newton is applied. So retarding force means the force which is applied opposite to the direction of the motion, so that we call as the retarding motion. So in the direction of motion alli ನಾವು force apply ಮಾಡಿದ್ರೆ force positive ಇರುತ್ತೆ, so opposite direction we are applying the force, so that force is equals to 50 Newton. So along the horizontal toward positive axis motion alli iದ್ರೆ opposite ಆಗಿ ನಾವು ಏನು ಅಪ್ಲೈ ಮಾಡ್ತಿದೀವಿ, force. So after certain time it will comes to rest. That means its final velocity of the object v is equals to 0. So what's the time to stop? Here we need to find the time t, right? So first we need to write the given, right? So given, first they given that force F is equals to 50 Newton, and they mention mass m is equals to 20 kg. So mention the speed. Initially it is moving, u is equals to 15 meter per second, right? So we need to find the time. T is equals to, again here one more quantity, that is v is equals to 0, because it comes to rest means its final velocity is 0, right? So to find t is equals to, we need to find, right? So by using the formula of force, that is equals to mass into acceleration, right? So ನಮಗೆ force ಗೊತ್ತಿದೆ, mass ಗೊತ್ತಿದೆ, but we don't know the acceleration. So this is the object which is moving in a straight line. So by the equation v is equals to u plus at. So from this we can find a is equals to v minus u divided by t, right? So ಈ formula ಇಂದ ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ, acceleration, right? So substituting here, f is equals to m into a is v minus u divided by t. So they mention retarding force. So retarding force means its force is negative. We need to take that one as minus, right? So substituting here minus 50, that is equals to mass 20 kg, v is 0, minus u is 15 divided by t. We need to find the time t, right? So minus 50, that is equals to 0 minus 15, that is minus 15, right? So minus 20 into 15 divided by t. So here minus and minus get cancels, right? So 5 tens are 50, 5 fours are 20, right? So t is equals to 15 fours are 60 divided by 10, right? So 10 ones are 10 six are, then time it takes to stop, that is t is equals to 6 seconds, right? So now ಇಲ್ಲಿ retarding force minus ತಗೊಳ್ದಲ್ಲ ಇದ್ರೆ f is equals to positive ತಗೊಂಡ್ರೆ, so here we get the plus 50, right? So plus, here we getting the minus, so time we getting minus 6, so So time namge yavaglu minus alli irolla. Time is always positive, right? So then if you get the answer t is equals to minus 6, then this answer will get wrong, right? So example idara diagram bariyo necessity illa, just given data you need to mention, and important is you need to write the formula. Without formula, if you substitute and simplify, you will get 0 marks, right? Take the second question. A constant force acting on a body of mass 3 kg changes its speed 2 meter per second to 3.5 meter per second. The direction of the motion of the body remains unchanging. What is the magnitude and direction of the force? What is the direction and magnitude of the force? So this is also similar to that of the previous problem, right? So in the previous problem we are applied the retarding force. So here we are applying the force in the direction of motion, right? So a constant force acting on a body of mass 3 kg, right? So if we consider any one object, so its mass is 3 kg. So on to this mass, so some force is acting on the object, right? So its speed changes from 2 meter per second to 3.5 meter per second. That means initially the object is moving with some speed, that is u is equals to 2 meter per second. After applying the force, so this object changes its speed to 3.5 meter per second. That means final velocity is 3.5 meter per second. So the direction of motion of the body remains unchanged. So now e directional force apply ಮಾಡ್ತಿದ್ರೆ ಈ directional ಹೋಗ್ತಾ ಇದ್ರೆ object ಕೂಡ in the same direction ಅಲ್ಲಿ ಹೋಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ಮೆನ್ಷನ್ ಮಾಡ್ತಿದ್ದಾರೆ, right? So here we need to find the force. So now ಎಷ್ಟು force apply ಮಾಡಿದ್ರೆ it changes its speed from 2 meter per second to 3.5 meter per second. Here in 25 seconds. So add this one. So here time taken to change its speed from 2 to 3.5 meter per second is 25 seconds, right? So again, first we need to write the given data. So for board exam ke given data ಬರ್ಬಿಟ್ಟು ಮತ್ತೆ formula ಬರ್ದು substitution and simplification. So 3 important steps, but competitive exam ali there is no necessity to write the given data, right? So given u is equals to 2 meter per second, v is equals to 3.5 meter per second, so mass 3 kg, time t that is equals to 25 seconds, right? So what we want to find, that is to find force acting on the object, right? So again from the Newton's second law, that is F is equals to m into a, right? So So F that is equals to M into A, we can write V minus U divided by T, because A is equals to V minus U by T. So we know mVu by T, so substituting we get the value of F. So mass is 3 kg, so final velocity is 3.5 minus 2 divided by 25, right? So 3 into 1.5 divided by 25. So 5 3s are 15, so 5 5s are 25. So 0.9 divided by 5, so that value is 0.5 ones are 5, so remaining 4, 5 8s are 0.18 Newton. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಯೂನಿಟ್ ಕೂಡ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ನೀವು ಯೂನಿಟ್ ಬಿಟ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ 1 ಮಾರ್ಕ್ಸ್ ಕಟ್ ಮಾಡ್ತಾರೆ. ಸೊ ಇಷ್ಟೊಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ್ದು ಕೂಡ ನಿಮಗೆ ವೇಸ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ಮುಲಾಗೆ 1 ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ, ಮತ್ತೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್, ಸಿಂಪ್ಲಿಫಿಕೇಶನ್, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಅಂಡ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಗೆ 3 ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಫೈನಲ್ ಆನ್ಸರ್ ಗೆ 1 ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ, ಜೊತೆ ಯೂನಿಟ್ ಗೆ 1 ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಯೂನಿಟ್ ಬಿಟ್ರೆ 4 ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ, ಫಾರ್ಮುಲಾ ಬಿಟ್ರೆ 0 ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. So board exam ge idara simple ಆಗಿರೋ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಕೇಳೋದು, that means direct substitution and simplification. So ಇವೆಲ್ಲ 5 ಮಾರ್ಕ್ಸ್ ಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಬ್ಲಮ್ಸ್. So next, third question: a body of mass 5 kg is acted. So previous problem only direction kelidu. So force 0.18 Newton and direction is, it is in the direction of motion of the object. So ಯಾವ direction ಅಲ್ಲಿ motion ಇರುತ್ತೋ ಆ direction ಅಲ್ಲಿ ನಮಗೆ force act ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು, right? So body of mass 5 kg acted upon by two perpendicular forces of 8 Newton and 6 Newton give the magnitude and direction of the acceleration of the body. So here considering one body of mass 5 kg. So on this body two forces are acting. So one force that is of F1 that is of 8 Newton and the another force F2 of 6 Newton, right? So force is a vector, they given the magnitude and these two forces acting perpendicular to each other. So perpendicular means the angle between the two forces is 90 degrees. So ನೀವು ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಬೇಕಾದರೂ ತಗೋಬಹುದು. If you take one force in this direction, so if you take another force either in this direction or in this direction, right? So ನೀವು F2 in between these two also ತಗೋಬಹುದು ಅಥವಾ these two also ತಗೋಬಹುದು. Otherwise you can take F1 in this direction, F2 in this direction, right? So ಅದು ನಿಮ್ಮ ಚಾಯ್ಸ್, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಬೇಕಿದ್ರು ತಗೋಬಹುದು. ಬಟ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಗೆ ಹೆಲ್ಪ್ ಆಗಬೇಕು ಅಂದ್ರೆ we need to take these two forces, that means pulling. So ಈ ಆಬ್ಜೆಕ್ಟ್ ನ ಪುಲ್ ಮಾಡ್ತಿರೋ ತರ ನಾವು ಎರಡು ಫೋರ್ಸ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ. Either we can take two forces either by pushing or by pulling. So here we taken these two as pulling, right? So here we need to find the magnitude and direction of the acceleration, right? So they're given F1 and F2, two forces, and the angle between those two is 90 degree. But I'll mention modula two perpendicular means it's always its angle is 90 degree, right? So what we need to find is to find the acceleration. So vector, that means to find the magnitude and direction, right? So these two are the vectors. So force F1 and F2, these two are the vectors, right? So first we need to find the resultant of these two forces. Again from the parallelogram of vector addition. So if we complete this one as one parallelogram, so we get the resultant in the direction of the diagonal. So diagonally namge ಏನು ಸಿಗುತ್ತೆ resultant of these two forces, right? So that is F12, right? So again by the formula F12 that is equals to under square root of F1 square plus F2 square plus 2F1 F2 cos theta. So this is the resultant of the two vectors. So resultant of two vectors here under square root of we have the formula a square plus b square plus 2ab cos theta, right? So here F1 and F2 represents the magnitude of the two forces, right? So we know those values, right? So under square root of F1 is 8 square, F2 is 6 square plus 2 into 8 into 6 into cos 90 degree, right? So cos 90 is 0, so 0 into this term, the whole term becomes 0, right? So under square root of 8 8 is 64 plus 6 is 36. So this is the magnitude of the force, right? So this is the magnitude of the force of these two resultant, right? But we need to find the direction of the acceleration. So e direction alli naven ಮಾಡ್ತಾ ಇದೀವಿ acceleration find out ಮಾಡ್ತಾ ಇದೀವಿ, right? So that is again from the formula F12 is equals to m into a, right? So a is equals to F12 divided by m. So ನಮಗೆ force ಗೊತ್ತಿದೆ ಎಷ್ಟು 10 divided by mass of the object is 5 kg, right? So acceleration a is equals to 2 meter per second square. So this gives what the magnitude of the acceleration, right? So magnitude siktu. So next direct. So we get angle theta is equals to 36.86. So ಇದು ನೀವು tan table ಅಲ್ಲಿ find ಮಾಡಿದ್ರೆ you get the theta. So theta represents what? The direction, right? So ಇಲ್ಲಿ theta ತಗೊಂಡ್ರೆ ನಿಮಗೆ that is 8/6 ಬರುತ್ತೆ. So ಅವಾಗ ನಮಗೆ theta value vary ಆಗುತ್ತೆ, right? So this gives what the magnitude 2 meter per second and the direction of the acceleration is 36.86. So ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಮಗೆ ಏನಿರುತ್ತೆ acceleration ಇರುತ್ತೆ because force ಯಾವ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಿರುತ್ತೋ ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಮಗೆ acceleration because F is equals to m into a. Force ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ acceleration ಕೂಡ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. Hence ಇಲ್ಲಿ ನಾವು force ಗೆ resultant force ಗೆ angle ಫೈಂಡ್ ಮಾಡಿದ್ರೆ acceleration ಗೆ ಕೂಡ ಸೇಮ್ angle ಇರುತ್ತೆ, right? So ಈ ತರದ ಪ್ರಾಬ್ಲಮ್ ಸ್ವಲ್ಪ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಇದು ನಮಗೆ ವೆಕ್ಟರ್ಸ್ ಅಲ್ಲೂ ಬರುತ್ತೆ ಪ್ಲಸ್ ಇಲ್ಲೂ ಬರುತ್ತೆ. ಐದರ್ ದೇ ಆಸ್ಕ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್ ಇನ್ ಪ್ರೀವಿಯಸ್ ಚಾಪ್ಟರ್ ಮೋಷನ್ ಇನ್ ಎ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಕೂಡ ಕೇಳಬಹುದು, ಇಲ್ಲೂ ಕೇಳಬಹುದು, ರೈಟ್? ಸೊ ಮೋಷನ್ ಇನ್ ಎ ಪ್ಲೇನ್ ಕೇಳಿದ್ರೆ ಓನ್ಲಿ ಅಪ್ ಟು ದಿಸ್ ರಿಸಲ್ಟೆಂಟ್ ಫೋರ್ಸ್ ಮತ್ತೆ ರಿಸಲ್ಟೆಂಟ್ ಆಂಗಲ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ ಹೇಳ್ತಾರೆ. ಇಫ್ ದೇ ಆಸ್ಕ್ ಇನ್ ದಿಸ್ ಚಾಪ್ಟರ್ ಮೀನ್ಸ್ ಆಕ್ಸಲರೇಷನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮತ್ತೆ ಆಕ್ಸಲರೇಷನ್ ಡೈರೆಕ್ಷನ್ ಕೇಳ್ತಾರೆ. ಸೊ ಎಲ್ಲ ಮೆಥಡ್ ಅಲ್ಲೂ ಒಂದೊಂದು ಪ್ರಾಬ್ಲಮ್. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ, ಅದನ್ನ ನೀವೇ ಟ್ರೈ ಮಾಡಿ ಸಾಲ್ವ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಸೊ ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. Fourth question. The driver of a three-wheeler moving with a speed of 36 kilometer per hour sees a child standing in the middle of the road, and brings his vehicle to rest in 4 seconds, just in time to save the child. What is the retarding force? On the vehicle. The mass of the three-wheeler is 400 kg and mass of the driver is 65 kg. So this problem is similar to that of the first problem. So ಏನು difference ಇಲ್ಲ. So similar to the first problem, but explanation ಕೊಟ್ಟಿದ್ದಾರೆ. So that is the condition or scenario. So mention ಮಾಡಿದ್ದಾರೆ. ಏನು ಹೇಳ್ತಿದ್ದಾರೆ? A driver of a three-wheeler. So that means some auto moving with a speed of 36 km per hour. That means it is moving with some initial speed. Sees a child standing in the middle of the road. So while driving, he sees or he observes a child. He is standing on the middle of the road and brings the vehicles to rest in 4 seconds. So brings the vehicle to rest. So it comes to my important. Rest and its final velocity is always 0, and that means v is equals to 0, right? So time they given just in this time to save the child, right? What is the retarding force? That means opposing force we need to calculate, right? So they mentioned the vehicle of the mass of the vehicle is 400 kg and mass of the person is 65 kg, right? So same here. First we need to write the given data, right? So initial speed, that is 36 km per hour. So we need to convert this in meter per second, right? So that is 36 into 5 by 80. So ಇದನ್ನ ನಾನು already first chapter ಅಲ್ಲಿ ಹೇಳಿದೆ. Kilometer per hour ಗೆ ಯಾವ ತರ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು? That is kilometer is 1 kilometer is equals to 1000 meter. So 1 hour is equals to 60 minutes into 60 seconds. That is 3600. So 1010 get cancelled. 1010. So 2 5s are 2 3s are. That means 5 divided by 18, right? So every time simplification ಮಾಡಬಹುದು. ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. Meter per second ಇಂದ kilometer per hour ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ we need to multiply by 18 divided by 5. So kilometer to meter per second. So 18 ones are 18 twos are, right? So u is equals to 10 meter per second. Next, the vehicle is come to rest. That means v is equals to 0. Time taken is 4 seconds, right? So here mass of the vehicle, that is 400 kg, then mass of the person, that is equals to 65 kg. So these are the given data. So here we need to find F. So second problem, right? Again by the relation, F is equals to M into A. So F is equals to M into B minus U divided by T, right? So here M is nothing but total system. So one vehicle is under vehicle mass kuda consider ಮಾಡ್ತಿದೀವಿ. Here M is what? M is the sum of these two. Mass of the vehicle plus mass of the person, right? So M is equals to MP plus MB, right? So that is equals to 465 kg. So ಇದಿಷ್ಟನ್ನು ನಾವು one system ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋದ್ರಿಂದ so ಎರಡು ಮಾಸ್ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಆಡ್ ಮಾಡ್ತೀವಿ, right? So F is equals to M is 465 into 0 minus 10 divided by 4, right? So F is equals to minus 465, that is 4650 divided by 4. 465 into 10, 4650 by 4. So if we simplify this one, 4 ones are 4, that is 4 ones are 4, 4 6 are 20. So if we simplify, we will get this answer, right? So 1162.5 Newton. So now simplify ಮಾಡಿದ್ರೆ ನಮಗೆ ಫೋರ್ಸ್ ಯಾವ್ದ್ರಲ್ಲಿ ಇರಬೇಕು, ಮೈನಸ್ ಅಲ್ಲಿ ಬರಲೇಬೇಕು. ಸೊ ಮೈನಸ್ ಅಲ್ಲಿ ಆನ್ಸರ್ ಬರಲಿಲ್ಲ ಅಂದ್ರೆ ಸೊ ಆನ್ಸರ್ ಏನಾಗುತ್ತೆ ನಮಗೆ ರಾಂಗ್ ಆಗುತ್ತೆ. ಮೈನಸ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ ವಾಟ್? ರಿಟಾರ್ಡಿಂಗ್ ಫೋರ್ಸ್. ಸೊ ನಾವು ಸೆಕೆಂಡ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ತಗೊಂಡಿದ್ವಿ ರಿಟಾರ್ಡಿಂಗ್ ಅಂದ್ರೆ there we taken F is equals to minus 50. ಸೊ ಇಲ್ಲಿ ನಾವು ರಿಟಾರ್ಡಿಂಗ್ ಫೋರ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ನಮಗೆ ಆನ್ಸರ್ ಯಾವ್ದ್ರಲ್ಲಿ ಇರಬೇಕು, ಮೈನಸ್ ಅಲ್ಲಿ ಇರಲೇಬೇಕು, ರೈಟ್? ಸೊ ನೀವು ಸಣ್ಣ ಸಣ್ಣ ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ರು ಕೂಡ ಆನ್ಸರ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ರಾಂಗ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಇಫ್ ಇಟ್ ಕಮ್ಸ್ ಟು ಪಾಸಿಟಿವ್ ಮೀನ್ಸ್ ಸೊ ದಿಸ್ ಈಸ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ವಿಚ್ ಈಸ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮೋಷನ್, ರೈಟ್? ಸೊ ತುಂಬಾ ಮೀನಿಂಗ್ ಇರುತ್ತೆ, ಪ್ಲಸ್ ಮೈನಸ್ ವೇರಿ ಆಯ್ತು ಅಂದ್ರೆ. So next problem, a man of mass 70 kg stands on a weighing scale in lift which is moving so first one, upward with a uniform speed of 10 meter per second. In that second one, downwards with a uniform acceleration 5 meter per second square. Again, upward with uniform acceleration of 5 meter per second square. And the last one, if the lift mechanism fail, and heat hurtled down, freely falling under gravity. So we need to find would what would be the readings, on the scale, in each case. So you important concept, but in the theory part alilla, but problem irodrinda explain ಮಾಡಲೇಬೇಕು, right? So when it is a man of mass 70 kg who is stands on a weighing scale in a lift. So before solving this problem, so first understand the concept on this question, right? So first initially one lift is there, right? So in lift alli one person idane. So person who is standing on the weighing scale, that means weight check ಮಾಡ್ತೀವಲ್ಲ ಆ ಸ್ಕೇಲ್ ಮೇಲ್ಗಡೆ ಸ್ಟ್ಯಾಂಡ್ ಆಗಿದ್ದಾನೆ, right? So ಇಲ್ಲಿ ನಮಗೆ 3 to 4 cases ಬರುತ್ತೆ, right? So initially the lift is at rest. So initially lift rest ಅಲ್ಲಿ ಇದ್ರೆ the person all in the lift is also in the rest. That means rest ಅಲ್ಲಿ ಇರಬಹುದು, or the lift which is moving with an uniform motion. So again uniform motion is nothing but moving with a constant speed. So ಅದನ್ನ ಎರಡು ತರನು ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂತೀವಿ. Uniform motion ಅಂದ್ರೆ the object is moving with the constant speed, that means v is equals to u, or we can also say that one as acceleration is equals to 0. So object uniform motion ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ rest, or in this condition that is uniform motion. So uniform motion ಅಂದ್ರೆ ಎರಡು ಕೇಸಸ್ ಹೇಳ್ತೀವಿ, ಒಂದು ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ ಅಥವಾ ಆಕ್ಸಲರೇಷನ್ ಇರೋದಿಲ್ಲ ಮೋಷನ್ ಅಲ್ಲಿ, ರೈಟ್? ಸೊ ಈ ಕೇಸ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ರೆಸ್ಟ್ ಅಂತ ನಾವು ಕರೀಬಹುದು, ಅಥವಾ ಆಬ್ಜೆಕ್ಟ್ ವಿಚ್ ಇಸ್ ಮೂವಿಂಗ್ ಇನ್ ಆನ್ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್. ಸೊ ಈ ಎರಡು ಕೇಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಮಗೆ, ರೈಟ್? ಸೊ ವೆನ್ ದ ಲಿಫ್ಟ್ ಈಸ್ ಅಟ್ ರೆಸ್ಟ್, ಸೊ ಲಿಫ್ಟ್ ಏನಾಗಿದೆ ನಮಗೆ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದೆ, ಅಥವಾ ಆರ್ the lift is moving with uniform speed. So lift ಏನಾಗ್ತಿದೆ, ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಯೂನಿಫಾರ್ಮ್ ಸ್ಪೀಡ್ ಅಲ್ಲಿ, or its acceleration is 0, right? So here the forces which are acting on this person, we need to find those forces. So ಎಷ್ಟು force ಈ person ಮೇಲೆ act ಆಗ್ತಿದೆ, right? So one force is that is due to gravity, that is weight of the person, that is W is equals to mg. So W represents what? Weight of the person. And the another force is normal force, right? So normal force is equals to mg when it is rest or in an uniform motion, right? So we can write n minus mg, that is equals to 0, right? So this we can write n is equals to mg. This is the first case when the object is at rest or it is in uniform motion. Then the forces acting on this person, that is n is equals to mg. That means the weight which is measuring of the person, so that weight we call as, this weight we call as true weight. So lift rest ಅಲ್ಲಿ ಇದ್ದಾಗ ಅಥವಾ ಲಿಫ್ಟ್ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಪರ್ಸನ್ weight ಮೆಜರ್ ಮಾಡಿದ್ರೆ ಏನಿರುತ್ತೆ ನಮಗೆ, ಇನಿಷಿಯಲಿ ಎಷ್ಟು weight ಇರುತ್ತೋ ಅಷ್ಟೇ weight ಇರುತ್ತೆ. ಸೊ ಅಂತ weight ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ಟ್ರೂ weight ಅಂತ ಕರಿತೀವಿ. So this is the first situation, right? So next, in the second situation, again considering a lift, so person who is standing on the weighing scale, right? So here the lift is accelerating in the upward direction. Lift ಏನಾಗ್ತಿದೆ, ಮೇಲ್ಗಡೆ ಮೂವ್ ಆಗ್ತಿದೆ with some acceleration a, right? So here first case, so this one is the second case. So now here we are going to find the forces which are acting on that person, right? So again normal, that is weight, W is equals to mg and the normal n, right? So now if I write the relation here, n minus mg, that is equals to m into a. So this is m into a is the force, that is the net force which is moving with the upward direction. So upward direction ಅಲ್ಲಿ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ನಾವು ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂತಿದೀವಿ. ಇಲ್ಲಿ the lift is at rest, hence we taken that one as 0. M into acceleration is 0, so that's why we getting the 0. Here m is the mass of the person, right? So n, that is equals to ma plus mg, right? So ಇಲ್ಲಿ ನಮಗೆ ಏನಾಗ್ತಿದೆ ma plus mg, where m is the mass of the person, we can write this one as m into a plus g, where g is the acceleration due to gravity. We call this weight is the apparent weight, right? So here observe model a plus g. So one more term is adding, that is mg. So here we call that one as true weight. mg na ನಾವು ಏನಂತ ಕರೀತೀವಿ, true weight ಅಂತ ಕರೀತೀವಿ. ಅದರ ಜೊತೆಗೆ ಎಕ್ಸ್ಟ್ರಾ ಟರ್ಮ್ ಆಡ್ ಆಗ್ತಿದೆ, that is m into a. A is the acceleration of the lift ಅಥವಾ acceleration of the person. So lift to accelerate ಆಗ್ತಿದೆ ಅಂದ್ರೆ person ಕೂಡ ಏನಾಗ್ತಿದಾನೆ, accelerate ಆಗ್ತಿದಾನೆ, right? So that means we can say apparent weight is more than the true weight, right? So ಇಲ್ಲಿ lift upward direction ಅಲ್ಲಿ ಇದ್ರೆ apparent weight is greater than true weight. So W apparent means apparent weight which is greater than true weight. So lift upward motion ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ರೆ person weight ಏನಿರುತ್ತೆ ನಮಗೆ actual weight ಗಿನ ಜಾಸ್ತಿ weight ಇರುತ್ತೆ, right? So that we call as the apparent weight. But ಯಾವಾಗಲೂ weight ಎಷ್ಟಿರುತ್ತೆ person ದು, for example here we taken 70 kg, so 70 kg ನ ಇರುತ್ತೆ. While moving in the lift, we getting the readings more than the 70 kg, right? So that we call as the apparent weight, right? So this one is the second case, right? So next in the third case, so the same lift and the same person who is standing on a weighing scale. So now the lift is accelerating downward. That means the lift is moving downward direction, right? So again here weight acting mg and the normal. So here we can take mg minus n, that is equals to m into a. So this is while in the downward motion, right? So we can take n is equals to mg minus m, right? So n is equals to m into g minus a. So this is also the apparent weight. So relation observe ಮಾಡಿದ್ರೆ one more term is adding minus a, that means initial weight minus, that means some weight is less ಆಗ್ತಾ ಇದೆ, that means subtract ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಕಡಿಮೆ ಆಗ್ತಿದೆ. That means in this case apparent weight is less than the true weight. So ನಮಗೆ actually person 70 kg ಇದಾನೆ ಅಂದ್ರೆ while the lift is accelerating downward ಅಲ್ಲಿ ನಾವು ಮೆಜರ್ ಮಾಡಿದ್ರೆ 70 kg ಗಿನೂ ಕಡಿಮೆ ಬರ್ತಾ ಇರುತ್ತೆ. That means weight 70 into 9.8 ಅಥವಾ 10, that means the force is lessing, that means weight ಏನಾಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ. So upward motion ಅಲ್ಲಿ ಇದ್ದಾಗ apparent weight is greater than the true weight and apparent weight is less than true weight when the lift is moving downward. ಅದು ನಮಗೆ ಫೀಲ್ ಆಗುತ್ತೆ, ಬಟ್ ನಮ್ಮ actual weight ಏನಿರುತ್ತೋ ಅಷ್ಟೇ ಇರುತ್ತೆ. That means mass. So ಇದು person mass is different from weight, right? So mass ಯಾವಾಗಲೂ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ಬಟ್ weight ಏನಾಗುತ್ತೆ, ವೇರಿ ಆಗುತ್ತೆ. So ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು, weight ಏನಿದೆ ನಮಗೆ ಇಲ್ಲಿ 700 ನ್ಯೂಟನ್ ಬಂತು ಅಂದ್ರೆ ಇಲ್ಲಿ more than 700 ನ್ಯೂಟನ್, in this case less than 700 ನ್ಯೂಟನ್. So these are the important formulas to solve the problems related to lift. So lift ಗೆ ನಾವು ಯಾವುದೇ ತರಹದ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕು ಅಂದ್ರೆ these three are the very important formulas. So ಅದು ನೆನಪಲ್ಲಿ ಇರಬೇಕು, ಕನ್ಫ್ಯೂಸ್ ಆಗಬಾರದು. ಲಿಫ್ಟ್ ಅಪ್ವರ್ಡ್ ಮೋಷನ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ weight ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಲಿಫ್ಟ್ ಡೌನ್ವರ್ಡ್ ಮೋಷನ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ weight ಏನಾಗುತ್ತೆ, ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಬಟ್ ಮಾಸ್ always remains same, right? Mass is a scalar, weight is a vector, right? So mass ಗೆ ಡೈರೆಕ್ಷನ್ ಇರೋದಿಲ್ಲ, it is only a magnitude, but weight ke direction weight change agutte but mass change agudiಲ್ಲ, right? So on the last one, fourth one, for a freely falling object, so lift free agi fall ಆಗ್ತಿದೆ, the rope cut ಆಯ್ತು ಅಂದ್ರೆ lift ಏನಾಗುತ್ತೆ, suddenly ಕೆಳಗಡೆ ಬರುತ್ತೆ to the ground floor. So movies ಅಲ್ಲೆಲ್ಲ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, so sudden ಆಗಿ ಏನಾಗುತ್ತೆ, ಒಂದೇ ಸಲ 10th floor ಅಲ್ಲಿ ಇದ್ರೆ sudden ಆಗಿ first floor ಗೆ ಬರುತ್ತೆ. That means under freely fall. So ಯಾವುದಾದ್ರು ಮೆಕ್ಯಾನಿಸಮ್ ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತು ಅಥವಾ ರೋಪ್ ವೇ ಕಟ್ ಆಯ್ತು ಅಂದ್ರೆ lift falls freely. That means acceleration of the lift is equals to acceleration due to gravity. That means A is equals to G and the lift will fall downwards. So here A is equals to G. That means this becomes 0. So 0 into M is 0. That means the normal or weight is equals to 0. So that case we call as weightlessness. So ಇದನ್ನ ನಾವೆಲ್ಲ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ವಿ in spaceships ಅಲ್ಲಿ astronauts they feel weightlessness. So ಅವ್ರಿಗೆ ಯಾವುದೇ ತರಹದ weight ಇದೆ ಅಂತ ಫೀಲ್ ಆಗೋದಿಲ್ಲ, right? So this is the case when freely falling is ಅಂದ್ರೆ A is equals to G and its weight is equals to 0. So that weight we call as weightlessness, right? So now the same here they ask mass is 70 kg. So first problem, upward with an uniform speed 10 meter per second. So uniform speed means uniform motion, right? So substituting here we get n is equals to 70 into 10 or 9.8, right? That is 700 Newton. So for the first case, if they ask for rest on the kedidru kuda namage same answer barutte, right? So next, second case, downward with a uniform acceleration 5 meter per second square, right? So this is for A, B, right? So that is n is equals to m into G minus A. So m is 70, G is 10 minus 5. So we get 350 Newton. Downward we have the formula n is equals to m into G minus A. So on the third case, lift moving upward. So n is equals to m into G plus A. So 70 into 10 plus 5. So 70 into 50. So 1050 Newton. This is for the third case by using this relation. N is equals to m into A plus G. And for the last one, mechanism failed and it's freely falling under gravity. So the D option is n is equals to m into G minus A. So here A is equals to G, m into G minus G, that is equals to 0, right? So remaining problem we will discuss in our next class. Thank you.